So in this video, I want to talk about the transition that happens in the late 1500s to early 1600s of our picture of the universe, from a universe centered on the Earth to one centered on the Sun. And in a later video, we'll talk about the evidence that finally confirms this view. We talked about the fact that this picture is the prevailing view of the universe from ancient times up until what we would call the scientific revolution, with the Earth in the center, and then everything else orbiting the Earth in some kind of circular orbit. The Moon, Mercury and Venus, the Sun, Mars, Jupiter, Saturn, and then around the edge, what we call the fixed stars, the stars in the sky that make up the constellations. And we've been taught something very different all the way through our education from the time we started learning about science in elementary school. We were taught that the Earth goes around the Sun and the Earth spins on its axis and stuff like that. So we might be tempted to ask ourselves, why would someone believe that the Earth is the center of the solar system and everything goes around the Earth? And that's a silly question, because the answer is that's what it looks like. If you go outside and you look at the stars over the course of the night, they go around in a big circle, and the sun rises and sets every day, and the moon rises and sets every day. And if we look at the sky, it certainly looks like everything is going around us in a circle. So it's a outdated view of the universe, but it's not an unreasonable view of the universe. It is based on observations, and it is based on drawing conclusions from those observations that are entirely reasonable in the year, let's say, 150 BC, when the ancient Greeks were trying to figure this out, or in the year 1500, when people in the Middle Ages and early Renaissance were trying to figure this out. A better question to ask is, why wouldn't people believe the picture that we now understand is the correct view, where it's the Sun that is the center of our solar system, Mercury and Venus and the Earth go around the Sun, Earth's moon goes around the Earth, that's the only thing that goes around the Earth, and Mars and Jupiter and Saturn all go around the Sun. And what makes it look like things are going around us in a circle is that the Earth also spins on its axis once every 24 hours, and that's the reason for this view. And if you think about that for a minute, and maybe you've thought about this yourself before, I think it's pretty obvious why people wouldn't believe this. It's kind of a crazy thing to tell someone that they're spinning around in a circle right now on a big ball that's also moving around the sun in another big circle, especially if there's no direct evidence to support that view. The geocentric picture, the picture with the Earth at the center, is common to so many ancient ideas and ancient civilizations that it's a little silly to attribute it to one person. But if we do attribute it to one person, the person who worked out the kind of detailed motions of the planets in this system was Ptolemy. So you see in the corner of this, it says the Ptolemaic system. And again, Earth in the center, then the Earth's atmosphere, and then the Moon, Mercury, Venus, the Sun, Mars, Jupiter, Saturn, and then the fixed stars. We can also associate the understanding of the reasons for this system, if you can call them that, date all the way back to Aristotle, who lived around, let's say, 350 BC. Aristotle was not a scientist, he was a philosopher. You may occasionally hear that the ancient Greeks invented science. Not really. They invented a philosophizing about the natural world that shared some features of science, but was not based on experimentation and quantitative measurement the way real, honest-to-goodness, post-scientific revolution science is. Nonetheless, Aristotle philosophized about nature. He wrote things about physics. He wrote things about the heavens. He wrote things about plants and animals, and wrote things about poetry, and wrote things about everything. Aristotle had an idea about how everything in the world worked. And he had explanations for anything you might want an explanation for. One of the explanations that was central to Aristotle's understanding of the world was a relationship between matter and motion, specifically a relationship between what something is made out of and how it moves. So if you ask Aristotle a question like, why does a rock fall when you drop it? Aristotle had an answer. It's because of what a rock is made out of. What is a rock made out of? You might have heard this idea that dates back to ancient Greece, that there are only 4 kinds of material that everything is made out of. Now, not all ancient Greeks believed this. There were ancient Greeks like Democritus, Epicurus, who believed in atoms. But some ancient Greeks, Aristotle included, believed in this 4 primary substances theory of matter. Those primary substances are, I think you probably know, earth, water, air, and fire. And everything is made out of some combination of those things. So you, as a person, are made out of a lot of water, some earth, because the food that we eat comes out of the ground, some fire, which is why we're warm, it's why we have a body temperature of 98.6 degrees, and obviously some air, because we breathe. So humans are made out of little bits of earth, air, water, and fire. A rock is made out of earth. If I take a rock and I let it go, what happens to it? Aristotle says it goes back to the place where it belongs. It goes back to its proper place in the universe, which is down there, where it came from. Same with water. If I pour out a glass of water, where does it go? It goes down towards the place where water goes, which is down on the ground, where the ocean is, right? So Aristotle's belief of substances having a proper place in the universe informed the idea that where the Earth is as a planet is in its proper place in the universe, which is the center of the universe, and the Earth couldn't be anywhere else, because if you moved it somewhere else, it would just go back to where it belongs again. So the reason a rock falls, according to Aristotle, is because it's going back to its proper place. It is having a natural motion to its natural location. What if you set something on fire? What happens to the smoke and the flames? They go up, because the natural place for air and fire is the sphere of atmosphere that surrounds the Earth. So the natural motion of smoke and fire is upwards. It's not a bad idea, it's not right, but it's not a terrible idea. But it explained, to Aristotle anyway, why rocks fall when you drop it. Why a heavier rock, when it lands on your foot, hurts more than a light rock, because it has more earth and it's trying harder to get back to the center of the universe. So this idea of natural substances, natural motions, and natural places was central to Aristotle's philosophy. Well, what about stuff in space? What about the moon? It goes around the Earth in a circle. It doesn't go up or down. It doesn't come crashing down to the center of the Earth. What about the sun? It moves in a circle around the Earth. What does this mean to Aristotle about the substance of the moon and sun? Can the moon be a big rock, according to Aristotle? No, because rocks belong down here. If the moon was a big rock, it would come crashing down to Earth. Can the sun be made of fire? No, according to Aristotle, fire belongs in the sphere of the Earth's atmosphere that surrounds the Earth. So the moon and the sun and the stars and the planets must be made of something else, some other element, a fifth element. That element is sometimes called ether or quintessence. Quintessence literally means fifth, like quintessence, fifth substance. The heavenly ether had the quality of being perfect. What do we mean by perfect? The earthly substances like earth and water can act on one another and cause change. For example, you can have a rock that's eroded by rain and wind. Those changes are caused by opposite substances working on one another. But according to Aristotle, the things in the sky never change. The moon always goes around in a month, and Mars always goes around in 2.5 years, and Jupiter always goes around in 12 years, and Orion always looks like Orion, and the Big Dipper always looks like the Big Dipper. The heavens are unchanging. If they're unchanging, that means there cannot be any opposite substance to the heavenly substance that could cause it to change. And that means that the motion of the stuff in the heavens is a perfect shape. The perfect shape, which has no corners or edges and never changes, is the circle. So Aristotle explained that the reason the things in the heavens move the way that they do is that they're made of some substance that is perfect and eternal and heavenly and never changes. And it moves in a circle because that is the natural motion of perfect stuff, because it's the perfect shape. Again, this isn't really a scientific explanation. This is a philosophical explanation based on certain assumptions about the natural world. This idea of the substance of the earth and the substance of the stuff up in the sky being different winds up over the next 1,500 years being absorbed by medieval Christian theology. In that, the earthly realm, down here where the people are, is corrupt and constantly changing. Corrupt in the sense of imperfect. This fits in perfectly with the story of the Garden of Eden, right? Humans are sinful, the earth is corrupt, the earth is constantly subject to change and decay and death. But the heavens, where capital G, the capital H heavens where capital G God lives, are perfect and eternal and unchanging. So this difference between what's sometimes called the sublunary realm, everything under the moon is made of earth, water, fire, and air, and the heavens, which are made of something other perfect stuff, actually fits in very, very nicely with medieval Christian and Western theology. What this means is that at some point, questioning the philosophy of Aristotle and his statements about substance and motion becomes akin to heresy. It becomes akin to questioning theological ideas about the difference between the heavens and the earth. There is this wrong idea that people have about the new sun-centered system where the earth is a planet moving around the sun. You probably have heard that people got in trouble for suggesting that the earth moves and goes around the sun. And one of the places they got in trouble was from the 17th century Catholic Church. It was during the Inquisition. And that this idea was considered heretical. And you may have heard a completely wrong explanation of why this idea was considered heretical. The wrong explanation goes like this. God created the earth, and the earth is the center of God's creation. And so taking the earth out of the center and putting it somewhere else, going around the sun, demotes earth from the most important thing to a less important thing and makes the sun the most important thing. That is wrong. That is not the theological objection to saying the earth moves. This is the theological objection to saying the earth moves. The heavens are perfect and eternal. The earth is corrupt and changing. To take the earth and make it a planet that goes around the sun in the heavens where everything's supposed to be perfect is to corrupt the perfect heavens with the sinful rock that is the earth. That was the theological objection. It was based on breaking this divide between the corrupt, changing earth, water, fire, and air world down here and the perfect, eternal, unchanging world up there. Now, this geocentric model, like I said, we associate the philosophy of it with Aristotle. We associate the mechanics of it, how the planets move, with Ptolemy. But it was the prevailing model in many cultures for many hundreds of years. And again, the term we use for this is the geocentric universe. And it's important to realize that there were theological implications to this picture. We've got the Earth, Lunae, that's Mars, Mercury, Venus, Solus, that's the Sun, Martis, Mars, Jovis, Jove, Jupiter, Saturn, and then the stars. But then out here, we've got Caelum Imperium Habitaculum Dei, the heavenly Imperium, the habitation of God et omnium electorum, the habitation of God and the elect, God and the angels and the people who have gone to heaven. So this picture, this geocentric picture, included, at least in Middle Ages, Europe, Christianity, culture, Earth, Moon, Mercury, Venus, Sun, Mars, Jupiter, Saturn, stars, then actual honest-to-goodness capital H heaven, where God and the angels and the people who go to heaven live. So that is part of this cosmology. The physical capital H heaven exists just on the other side of the sphere of the stars. And we will come back to this when we talk about what kind of shift is involved if you change this picture. Okay. In 1542, 1543, Nicholas Copernicus published a work called On the Revolutions of the Heavenly Spheres, based on an earlier work of his called the Commentariolus, the Little Commentary. It was about 25, 30 years earlier. In Copernicus' system, he puts forward a heliocentric system where the sun is at the center, Mercury, Venus, and the Earth go around the sun. The moon goes around the Earth. Mars, Jupiter, Saturn go around the sun. The stars are out here, but the stars don't have to move in a big circle because it's the spinning of the Earth that makes the stars look like they're moving in a big circle. So the stars in the Copernican system are stationary. There are many reasons for the Copernican system, but the main one is simplicity. That Copernicus realized that instead of making all of the things move in little circles to explain what happens in the sky, if you just make the Earth move, it makes understanding the motions that happen in the sky just easier. I'll give you one example of the way the Copernican model makes life easier to understand the motions of the planets. We have talked about this before, that planets appear in a slightly different position every night, and as they move, they will sometimes change direction for a few weeks and go backwards and then go in the original direction again. That backwards motion is called retrograde motion. So every night you go and look at Mars, it usually goes this way, but for a couple of weeks it goes back the original direction again, and then every night it moves back. Excuse me, the way it was moving before. Now, Aristotle's view of the heavens and the prevailing philosophical view of the heavens from the ancient Greeks through the Middle Ages was that the heavens had to be eternal and unchanging. Well, that doesn't look eternal and unchanging to me. It looks like Mars is going this way, says, I'm going to go this way for a little while, and then changes direction and comes back again. How do you explain this changing motion of a planet in a system where everything is supposed to be eternal and unchanging? This is the solution that Ptolemy came up with, and this is why the geocentric model is usually referred to as the Ptolemaic models, because he came up with this explanation for retrograde motion, which is that everything moves in a circle, but sometimes more than one circle. That Mars moves around the Earth on an orbit, but it also moves around on its orbit in this little circle called an epicycle. So Mars is always moving in a circle. It's always moving in two circles. And the little circle moves around on the big circle. And as it does that, the motion of Mars has this kind of loopy motion that seems to change direction, even though the speed of Mars on its circle number 1 and circle number 2 never change. So it gives the appearance of Mars changing direction when it is really always just moving in two little circles. It's similar to, there's this toy, which I don't know, do people still play with physical toys? Maybe there's an app that does this now. But there's a toy that was popular back when I was a kid in the 70s, which is a bunch of little plastic gears, and you pin them down to a piece of paper, and you stick your pen in one of the gears, and you roll it around on the other gear, and it makes these cool spiral pictures. Okay, that is the epicycle model of Ptolemy, and it explains the occasional backwards appearing motion of the planets. So Mercury, Venus, Mars, Jupiter, Saturn all have orbits around the Earth, but they also all have epicycles on those orbits. It's actually way more complicated than that. We'll talk about that later. In the Copernican model, we explain retrograde motion like this. Earth also moves around the sun. And the further you get from the sun, the slower the planets move. So Mercury moves the fastest, then Venus, then Earth, then Mars, then Jupiter and Saturn. So Earth moves in its orbit faster than Mars. So as Mars moves around on its orbit, it appears to be going one direction, except for when we pass it. When we pass it, just like if you're in the fast lane looking at a car in the slow lane, it looks like for a while that car is going backwards relative to you. I used to teach in New York City, and I would explain it in terms of the subway. If you're on the express number 2 and somebody else is on the local number 2, and you look out your window, it looks like the local number 2 is going backwards when you're passing it. So Mars never changes direction. It only looks like it's changing direction when the Earth catches up to it and passes it. It looks for a little while like it's going backwards. So you can explain all of the retrograde motions of all of the planets with just the one extra circle of the Earth's motion, instead of having them all have to have their own epicycles. So the Copernican model is simpler, at least in this simple way, the straightforward way of looking at the motions of the planets. The fact of the matter is, from, say, 1550, the time shortly after Copernicus's work was published, to 1600 or so, both the old geometric system of Aristotle and Ptolemy and others, and the new heliocentric system of Copernicus, they both did an okay job of explaining what we see in the sky. Neither of them were super accurate with just one extra circle. I just showed the Ptolemaic model with one epicycle. If you try to predict where the planets are going to be, I want to know where Mars is going to be in 2 weeks. So I figure out the size of Mars's orbit, I figure out the size of Mars's epicycle, I figure out how fast the epicycle moves on the orbit, I figure out how fast the epicycle moves, or Mars moves on the epicycle. And I fiddle with those numbers until I try to predict where Mars is. And I can get it right for a few weeks. But if I try to make a prediction a few months or 6 months or a year down the road, I wind up off a little bit. And no matter how much I fiddle with those epicycles, I can't get it right. What did Ptolemy do? He's like, well, I'll put another smaller epicycle on this epicycle. So there's an orbit, an epicycle, and sort of an epi-epicycle. Now I've got 6 numbers to mess with, right? The size of this orbit, the speed of this orbit, the size of this epicycle, the speed of this epicycle, and the size of this little one, and the speed around this little one. I'll mess with those numbers, and I'll try to find out where Mars is. Still doesn't work. There were some models eventually by the end of the Middle Ages that had as many as 7, 8, 9 epicycles for each planet, a wheel and a wheel and a wheel and a wheel and a wheel. Copernicus didn't do much better. You couldn't, no matter how fast you made the Earth move and how fast you made Mars and Jupiter move, you couldn't ever get your predictions to be exactly right. So they were both just sort of okay. They weren't perfect. There was not a slam dunk where people said, oh my God, Copernicus's idea is so much better, let's switch. In fact, just the opposite. I have a book in my office, I should have brought it with me, about Copernicus's work. His work was called On the Revolutions of the Heavenly Spheres, the thing he published in 1543. And this book about Copernicus's book is called The Book That Nobody Read, suggesting that nobody paid any attention to Copernicus and his idea when he published it. Now, there's a whole big story about the publication of On the Revolutions of the Heavenly Spheres that I could do an hour-long video on all by itself. Copernicus was on his deathbed when he allowed On the Revolutions of the Heavenly Spheres to be published, partly because he knew there would be controversy. He knew this would be a controversial idea, and he was afraid to publish it in his lifetime. He actually died shortly after it was published. So in Copernicus's lifetime, not many people knew about this. And for the next 50 years or so, from say 1545 to 1600, only scientists and astronomers and mathematicians who studied this stuff professionally knew about Copernicus's idea. And it didn't make a big impact broadly in the community of, they wouldn't have called themselves scientists at the time. They would have called themselves natural philosophers, people who study nature, or simply mathematicians who were interested in predicting the positions of the planets. Copernicus's idea would not make an impact until there was some kind of evidence to discriminate between these two models, between the old geocentric model and the new heliocentric model. That evidence would come from Galileo Galilei and Galileo's telescope a generation later. Galileo started making observations with his telescope in 1609. So this is about 60 years post-Copernicus. So there's this little window of time from, say, 1545 to 1605, where you could kind of believe in whichever one of these systems seemed the most sensible to you. But there were lots of reasons not to believe the new Copernican system, because the old geocentric system was supported by our understanding of motion and how the world works. There was no reason to believe that the Earth moved because that contradicted everything we understood about motion and orbits and the reasons why things move. So Galileo had to do more than just provide observational evidence for the Copernican system. He had to invent a new physics that replaced Aristotle's wrong physics with some new physics in which the Copernican model made sense. And we'll talk about that in a separate video.